Hello and welcome back to a Physionic video. Today we're going to be discussing the topic of NSAIDs and their impact on muscle hypertrophy, or muscle protein synthesis if you want to get a little more specific with it. We will be covering what NSAIDs are. We're going to be covering if they have an impact on muscle hypertrophy, and if they do, what kind of an impact, and we're also going to delve into a little bit of the physiology as to the reasoning for their impact or lack of impact on muscle hypertrophy. Now, when I first entered this article, I initially thought that I knew the answer, and surprisingly, this article was one of the most difficult that I've had to write because I had to read quite a bit of research to get to any sort of conclusion, and you'll see why. I initially thought that the answer was going to be extremely clear because I'd heard many other people talk about it, but I feel that the research, the body of data is misrepresented by a lot of people. So this should be a really interesting, unique take, and hopefully as unbiasedly as possible I'm presenting the research for you. So that said, there's a menu system, of course, as usual, to skip to various parts, and that will be linked below as well as after this introduction. And feel free to make your own assertions and check out the article with all of the peer-reviewed research that I looked at down below. Okay, so we shall get started. Let's do it. Again, first things first, what is an NSAID? An NSAID is a shortened version, acronym for non-steroidal anti-inflammatory drug. And that's a big fancy term for basically talking about ibuprofen. Ibuprofen, acetaminophen, I think Aleve is a specific brand. Anything on the bottle, you should see any sort of over-the-counter painkiller, you should see on the bottle. If it is an NSAID, I think Tylenol is not. I'm not 100% certain on that, but you can just look on your bottle and it'll say this is an NSAID. So that's what we're talking about, over-the-counter drugs for pain relief. Alrighty, do NSAIDs impact muscle hypertrophy? Again, I came into this honestly thinking that I knew the answer. And after reading about 11 research studies, I have changed my opinion on it. Initially, I thought that yes, they do have an impact. However, now I'm leaning towards no, they do not have an impact. And the reason being is that there are several studies that show that yes, NSAIDs have a profound impact, as a matter of fact, on muscle hypertrophy. So a negative impact, decreasing muscle hypertrophy, which means decreasing muscle growth. And if you're not familiar, muscle protein synthesis needs to exceed muscle degradation for us to see a growth in muscle. That's one of the key tenets that need to happen. So again, there are several studies that say yes, NSAIDs decrease protein synthesis, and therefore they have a negative impact on muscle hypertrophy. However, these studies, all of them that are extremely conclusive, tend to be on rat models, so rodent models, and then there's also one or two human trials that have also said the same thing. And while the methodology was quite good, as a matter of fact, in these studies, they are in the minority, which is kind of surprising that you have this strange divide between one and the other. On the other side, however, the group that says no, they do not have an impact on muscle hypertrophy? Well, there are many studies, and all of them being human studies, that say that no, NSAIDs do not have an impact, or not a significant impact, statistically significant impact on muscle hypertrophy. Oddly enough, one of the main human studies that said yes, it does have an impact, actually then came out with a study a few years later looking at that same concept of NSAIDs on muscle protein synthesis and came to a completely different conclusion. So I'm sure they were quite confused. As a matter of fact, they kind of were in the discussion, because their hypothesis was based on their previous study that muscle protein synthesis would be blunted because of NSAIDs. So most of the human research seems to point to no, NSAIDs do not have an impact, and most of the animal and just very few human studies do indicate that yes, it doesn't have an impact. So I will lean towards no based on the current available research. That said, we're not going to leave it there, because I would like to kind of go into the physiological reasoning behind some of this confusion and some of the mechanisms that have been identified for what causes this lack of blunting in muscle protein synthesis in certain studies, and why there is a blunting effect of muscle protein synthesis in other studies. So I'm going to try and make my best effort to try and explain this to you, because even the researchers themselves are rather confused on this topic. So it's certainly not as black and white as a lot of people like to make this subject out to be. It definitely is not. So for us to do that, let's go ahead and go to the next section. Alright, for us to understand the physiology, I do want to switch to a blackboard method so I can give a little bit of an anatomical, a cellular understanding of the two prevailing theories, or two of the more common theories, I suppose I should say, which aren't with their own faults, without fault. They do have their faults, but again, we're just a little confused in the scientific community when it comes to figuring out what the mechanisms are for why muscle protein synthesis is blunted in certain instances and why it's not blunted in other instances. So without further ado, we will switch to a blackboard method so I can give you more of a visual. Okay, so here we are in the blackboard method, and as you can see, we've got two different images. I'm not going to go over all of the anatomy of the muscle cell or anything like that, because I've got an entire video on that, as a matter of fact, so feel free to check it out. I've got it linked. I will have it linked in the description box. So, but anyways, we should understand a little bit of the anatomy and function of the muscle fibers. So, as we know here, this is the main muscle belly, goes into the fascials, and then we end up with these muscle fibers. And this membrane here is essentially this thin layer here of the muscle fiber. And we'll go back to this, but this is just the site of damage. So when we exercise, we create damage in this muscle fiber, and then we have a whole lot of different reactions, again covered in more detail in my other video. But what happens then is one of the prevailing theories for muscle protein synthesis and why it occurs is due to inflammation. So as we create this damage in the muscle fibers, then that leads us to the body ends up creating inflammation to kind of address that issue. Like, hey, there's going to be pain, there's going to be soreness, there's going to be an overall uncomfortable nature about it, and that kind of tells the body, okay, we need to focus our energy on repairing that area. So one of the pathways or mechanisms by which the body knows that it needs to deal with some level of inflammation is through an enzyme called cyclooxygenase, which is abbreviated as COX. There's 3 different versions of COX, but there's 2 of them that are located in the musculature, or most predominant in the musculature. And this enzyme actually ends up secreting a autocoid, which is a kind of like a hormone, a lot like a hormone, called prostaglandin. And this prostaglandin is the main method by which the body is then able to create this inflammation around the damaged site. So we've got this damage here from our resistance training, and then we go up here, and from arachidonic acid, which is fatty substance, I'm not going to go into that, but it actually comes from our nutrition, or it can come from our nutrition. Then these COX-1 and COX-2, again, are the most predominant versions of this, or isoforms is the correct term, of this enzyme, which then secrete these prostaglandins, and then there are various prostaglandins based on the type of tissue that you're talking about, but we're just talking about them in general. So that's the way the mechanism is supposed to work. Now, NSAIDs tend to enact a change by binding to these COX enzymes, leading to an inability for that enzyme to create prostaglandin. And that's how we see a reduction in inflammation. That's how we see this reduction in inflammation. And then the thought process is that if we see a reduction in inflammation, then we'll see a decrease in muscle protein synthesis, because the body won't be as aware of what's going on. It won't be aware of the amount of damage that's been caused. So, well, that's a very simplistic view, but that's at least a general understanding of how this occurs. Now, the issue with that is that there's actually been a few studies that have looked at NSAIDs that specifically focus on COX-2, okay? So they've inhibited COX-2, and they've seen that there is no difference in muscle protein synthesis. However, we don't have any NSAIDs that only focus on COX-1, which is problematic, because then it's hard to tell if we downregulate COX-1, if then we would see a decrease in muscle protein synthesis. However, some of the studies that have looked at an inhibition of both of them have seen a decrease in muscle protein synthesis. But again, it's difficult to determine what exactly happens. So somewhere in this mechanism, something is going on, and again, we're not sure what, but something is going on that's leading to a decrease or a lack of a decrease in muscle protein synthesis. Now, one of the theories is that if we use NSAIDs that are non-specific, or even if they are specific, it's possible that they might affect one of them more than the other. And in that case, it's possible that we have an upregulation in one of them. So if we've got NSAIDs that affect COX-2, that we have an upregulation in COX-1, which would then take over or change in some way, and then be able to still produce this prostaglandin. Or if we've got a non-specific NSAID that doesn't necessarily just affect COX-2, but affects both of them, it could maybe favor one or the other. Another possibility is people in different conditions. So people that have maybe osteoarthritis or are typically older. They typically have a little bit more inflammation all throughout. So systemic inflammation, meaning that they would have an increase in both of these, and actually the third isomerase as well. So they would have an increase in all 3 of them, which would lead to NSAIDs having an effect, but not enough of an effect to see a decrease in muscle protein synthesis. So that's one of the mechanisms by which we understand NSAIDs to have an impact on muscle protein synthesis, but we don't fully understand why in certain cases, or in a majority of cases, NSAIDs seem to have no discernible impact on muscle protein synthesis, and in other cases, like those rodent models, we do see NSAIDs having an impact on muscle protein synthesis. Alright, on the other hand, we've got satellite cells, which is the second kind of prevailing idea as to this change or lack of change from in muscle protein synthesis, which is usually measured by the size of the musculature, but can also be measured in other ways, like the phenylalanine infusions. So there's, and I'm sure there are other ones as well. But anyways, measuring satellite cell activity, there's actually pretty conclusive data saying that satellite cells are downregulated when a person ingests NSAIDs. So what are satellite cells? Again, we're going to go back to this muscle fiber. A satellite cell is just under this main canopy of the muscle fiber, if you will, right under the membrane or between the membrane. And you get a better visual here. It's right between the membrane. So right under the outside layer and between the inside layer. And these cells are extremely small because this right here is an entire cell. It is a muscle cell, and a satellite cell, on the other hand, is extremely small and is able, if we create damage, again, we have this damage here. So this is a muscle fiber just like this is. If we create damage, these satellite cells actually end up migrating over to the damaged area. And it's actually a really cool process. However, before they do that, they go through this process over here. And through this process, they are activated, and then they proliferate, meaning that they just grow into more, and then they differentiate, which would then they differentiate into myotubes, which then integrate themselves into the actual muscle fiber to make it larger. One of its aspects is to make it larger. However, it also then renews itself. So NSAIDs actually have most of the impact that they have is on this activation. So it's activated, and then you just don't see as many proliferate as you would if you weren't to take NSAIDs. Now, again, this comes down to, well, then you'd think then the data would show you have a decrease in muscle protein synthesis because we have a proven method right here that satellite cells are decreased due to NSAIDs. Not a permanent decrease by any means. Just after exercise, you would see an increase in satellite cell activity for a brief time, and if you take NSAIDs, you don't see that activity. Now, there is an explanation for this, and this is what the prevailing idea right now is, that another mechanism that satellite cells have is when there is this damage in the surface of the muscle fiber, and these satellite cells move to integrate themselves into the muscle fiber. Other than when they differentiate, they can also donate their nucleus, because the majority of the satellite cells made up of a nucleus. Now, the reason why that's important is because we need something called a myonuclear domain. And a myonuclear domain is the amount of muscle fiber area or amount per nucleus. So you can see here that we've got several nuclei integrated inside one muscle fiber. So that being the case, if a satellite cell then drops off its nucleus and integrates that into the muscle fiber, then we've got an extra nucleus on top of the nuclei that we already have. So the myonuclear domain would then decrease. So then that would mean that you could have muscle protein synthesis increase up to a point before you would need another nucleus, because there's a maximal amount. So if I can illustrate this. So these are nuclei, right? Okay, so these blue things are nuclei. Let's say this nucleus is responsible for this much of the muscle cell. This nucleus is responsible for this much of the muscle cell. This one is this one, and this one just takes over the rest of the job. Okay, kind of a bad illustration, but hopefully you get what I mean. So that would mean that just because these don't necessarily integrate themselves does not necessarily mean that at the beginning that you have a maximal myonuclear domain. which means that the nuclei that are already there could potentially supply enough of a myonuclear domain, enough nuclei to not only support what's already there, but could support extra muscle protein synthesis. So that would mean that there would be a kind of an independent relationship, slightly independent relationship between muscle protein synthesis and satellite cells. So you wouldn't necessarily need more nuclei to make muscle protein synthesis go up, at least initially. However, in highly trained individual, you would need more myonuclei, because eventually that muscle protein synthesis just keeps going as you keep stimulating through repeated bouts of exercise, and then you reach your maximum. You reach the maximum myonuclear domain. And then the body has to rely on these satellite cells to supply these nuclei, which then get integrated, and then suddenly we have more nuclei, which means muscle protein synthesis can continue. But up until that point, we don't necessarily, and again, this is just a thought process so far, we don't necessarily need more satellite cells in initial phases. I'm not sure of exactly how long that would be, how long an initial phase would be. It could be weeks, could be months, could be years, could depend on the person. But in an initial phase at least, you could see an increase or a normal muscle protein synthesis, even though we have proof that satellite cell activation is decreased due to NSAIDs. So that is an explanation. Hopefully that made sense. This is the summary of the video for those of you that need a quick recap. If not, please subscribe and check out the attached article. And for those of you that just want an answer real quick, the answer was very gray. There was no black or white like a lot of subjects. You can't really, there isn't a distinct line, oh yes, this is the case, this is not the case. There are some studies that showed, those rat model, those rodent model studies typically showed, yes, there is a blunting effect in muscle protein synthesis, so there is a reduced level of muscle growth when a person takes NSAIDs. Especially, and this is just at over-the-counter doses. We're not talking about extra physiological or super physiological doses of these NSAIDs. And there's also one or two human studies that are well done that also say, yes, there's a blunting effect. Now, on the other side, there are many human studies that have said, no, there is no impact of NSAIDs on muscle protein synthesis and therefore also muscle hypertrophy. So how to make sense of that? Well, that's a little difficult and we don't really 100% know. But what we can, most likely it's going to be conditional. So again, elucidating those conditions is going to be difficult, but it seems like in younger, healthier populations that, and even in short-term studies, that muscle protein synthesis may be decreased. So for an athletic population, yeah, it might make a difference. However, if you're talking about the average person, if you're talking about a person who's, especially elderly people, NSAIDs will not have an impact. And there are several studies that are pretty clear that show that there's no impact of these NSAIDs. So again, it's kind of that gray scale. Overall, if you take some NSAIDs for a few days, is it going to have an impact? No. You will see no impact. No, you will actually, in an applied sense, which you will see, you will not see an impact. So I would not worry about it at all. But in terms of just an educational perspective, the topic is rather hazy. And if you have a person that says that they're 100% certain, then they're probably wrong, because no one is 100% certain when it comes to this topic. And of course, check out my article below where I go over some of these uncertainties and explain how some of this research is skewed in one way and other research is pointing to a completely opposite direction. Okay, so if you found the information useful, please subscribe. It certainly means quite a bit to me when I see that subscription number increase. And I encourage you to make your own decision, of course. Check out my sources, check them out. They're all linked below in the article that I've written that is congruent to this video. So, without further ado, I will see you next week, and I hope you have an awesome day. See ya.